Hello everybody, this is Dr. Christopher White, and in this presentation we're going to continue thinking about streams and flooding. So in this video we're going to look at what factors influence the profile of streams, and this is going to correspond to section 16.4 of your textbook. So in front of us we can see we have a vertically exaggerated profile for the James River in Virginia. So over here on the left you can quite clearly see we have an area of elevated terrain, and over here on the right we have an area of relatively flat terrain. So you'll notice that as we progress from the headwaters of the river over here on the left towards the mouth of the river, we can see that we have a steady decrease in the gradient. Now, to be clear, this particular diagram is vertically exaggerated, and so this makes the elevation look a lot higher than it really is. So what does this actually tell us? Well, as we know, streams tend to be steeper near their origin, and the origin tends to be associated with areas of topography, so hills and mountains, for instance. And of course, we know this is going to produce a steep gradient, which means the water moving through the channels in that area is going to be dropping quite quickly, so it's going to have a lot of energy. And of course, this means it not only has the capacity to transport larger class sizes, but it also has an increased capacity for erosion, because that water is just far more energetic. Now, as the river progresses downstream towards its mouth, we can see that the gradient becomes a lot more gentle. So we're decreasing in steepness essentially. And this is going to lead to the water becoming less energetic, and so its ability to erode is going to become somewhat more limited. Now, you'll notice that this particular profile is what's referred to as a concave upward profile. So you can see we have this curve, and what's going to happen over time is the river is going to attempt to erode away any imperfections in this profile. So if we look over here, we can quite clearly see we have this undulation in the profile right there. Well, over time, what's going to happen is the river is going to try and remove this and just produce a smooth path instead. So the river is going to try and smooth out its profile, and this is going to mean the river will be able to flow at maximum efficiency. And in doing so, and trying to smooth out its profile, it's going to produce what we refer to as a concave upward profile. So when we look at a river, the river can only go and erode down to what is referred to as its base level. And the standard base level, the ultimate base level, should I say, is sea level. So we know that rivers cannot erode below sea level. So if we just go back to the previous diagram here for a second, we know if sea level is right here, that our river will be incapable of eroding below that point. So all of this material above sea level is in theory erodable. It can be removed in an attempt for the river to try and achieve that perfect concave upward profile. In contrast, once our river makes it to sea level, it will be unable to erode down any further. So base level is the lowest point to which our river can erode. So when we look at river profiles, what do we tend to see? Well, in most instances we find that our rivers will originate in mountainous or at least very hilly terrain. And because we have very steep gradients in these areas, it means the water is going to be dropping very quickly, so it's going to be very energetic, and this means that it will tend to cut downwards very, very quickly. And this downward cutting of the rivers will tend to produce quite deep, quite steep-sided valleys. And you can see them here in this diagram. You can see these very steep-sided V-shaped valleys up here in the mountainous terrain. Now, as we progress from the mountainous terrain over here to the plains down here, you will obviously be able to see there is a decrease in the gradient. So the gradient is steadily getting gentler as we move from the headwaters over here towards the mouth of the river over here. Now, you'll notice in between we have these foothills here where the gradient is shallowing out, and then eventually we make it onto the plains themselves. And once we're onto the plains, the gradient tends to be a lot gentler, the water tends to move more slowly, and the area which we consider the plains tends to be associated with floodplains. So the rivers passing through these areas will tend to deposit sediment as they flood. Now, this is quite helpful because if there's a depression in this area, what will happen is over time that depression will begin to be filled in, and this is one of the ways that a river helps to achieve that perfect concave upward profile. So we know that if there's some kind of undulation in the profile, the river will erode it away. But what happens if there's a depression in the profile? Well, what will happen is over time that depression will steadily get filled up with sediment, and therefore it will allow that profile to be smoothed out. Now, we know, of course, as we've already discussed, that the river will be unable to erode past base level, and of course the ultimate base level is sea level. So once our river makes it down here to sea level, that's it. It can't erode any further down. It can erode sideways, but it can't erode any further down. So when we look at this diagram, we can see the landscape reflects a decreasing gradient and how high above the base level you are. Typically, the higher above the base level you are, the more energy your water will have, and so the more erosion will be taking place. So we can expect this area up here, where we have the elevated topography, to be an area of very, very high rates of erosion, creating large quantities of sediment. But as we progress into these lower gradient areas towards the plains and eventually towards the coast, we are moving into lower energy environments where there's actually probably going to be more sediment deposition than erosion. So the final thing we need to think about are what factors influence or change river profiles. So the first factor we're going to think about are the rocks over which our river passes. So if we look over here, you can see we have two block diagrams. The block diagram on the left consists of 3 layers of rock that have approximately equal physical properties, and so they will erode at around the same rate. This means the rate of erosion, as I said, will be relatively consistent along the entire length of the river, and so it will mean our river will be able to establish a nice smooth profile relatively quickly. Now, the block diagram over here on the right, on the other hand, represents a situation where we have layers of rock which are difficult to erode and layers of rock which are easier to erode. Now, typically, the more difficult a layer of rock is to erode, the steeper the gradient will be. So if we look at our diagram here, we can see we have this yellow-brown layer of rock here and this yellow-brown layer here, which both present steeper gradients than the other layers. So these are more likely to be the more robust, difficult to erode layers of rock, in contrast to the brown and black layers that we can see there. So the fact that these layers are more difficult to erode means that the river will obviously take longer to remove them, while these softer layers will erode more quickly, and it will end up producing this rather distinctive stepped pattern. Now, the key thing to remember is that given enough time, the river will eventually be able to remove these difficult to erode layers, and so it will eventually achieve a nice smooth profile like the one we can see here, but it's just going to take more time. So the next factor that's going to influence the profile of our river is going to be sea level, because sea level is the ultimate base level. So if the sea level changes, that changes the base level for our river, and so our river will either have to erode or deposit sediment to account for this change. So in our first model over here, we have a situation where the base level is dropping, so global sea level is going down. Well, because the base level is dropping, that means our river will be able to erode to a deeper level, won't it? And so this means that during periods when we have sea level decreasing, it causes rivers to erode downwards. In contrast, when we have sea level rises, this is obviously going to push the base level further up the river system. And so this is obviously going to lead to a change in how the river operates. So what we're going to see is, in this kind of situation where we have rising sea levels, we're going to see the river depositing more sediment closer to the coastline. In contrast, we are then going to end up with higher rates of erosion over here in the areas of more elevated terrain. So you can see how this change in sea level, and therefore the change in base level, is going to have an effect on the profile of our river. Now, the next factor that's going to affect the profile of the river is going to be tectonics. More accurately, whether the ground is being pushed up or whether it's subsiding. Now, in the event that the ground is uplifted, so pushed up due to tectonic forces, what's going to happen? Well, as the ground gets pushed up, it's obviously going to increase the gradient. This is going to give the water in our river more energy, and so it's going to be able to erode more efficiently. And so what tends to happen is when you have areas which are being actively uplifted, rivers will tend to erode downwards very, very quickly. And so this will lead to the formation of canyons, the Grand Canyon being a prime example of this process. Now, if you have the reverse situation and the ground starts to subside, that's going to cause the gradient to decrease. This means the water is going to have less energy, and so it means its ability to erode is therefore going to be reduced. It also means because the water has less energy, it's going to reduce the capacity of that water to move sediment. And so what you're going to see happening is you're going to see much higher rates of sedimentary deposition. And you can see that in this diagram here. As the gradient is decreasing due to the subsidence, we can see we end up with more sediment being deposited down here towards the plain region of the river profile. So the next factor that can affect our river profile is going to be climate. Now, climate is actually a bit of a difficult factor to discuss because it can cause so many different variations in our river profile. So the first thing we need to think about is how much precipitation is our area getting. Typically, areas which receive large amounts of precipitation will typically have large amounts of water that go into the river system. This obviously means you produce larger rivers, and larger rivers typically have an increased ability to erode. And so very often what we see is in areas where we have high rainfall, we will typically see rivers that have the capacity to smooth out their profiles relatively quickly. Now, in contrast, there is actually a counter argument to this. Typically, areas which have high rates of rainfall will also be very heavily vegetated. And so this will often lead to the soil or the rocks being more tightly bound together due to the root systems of the abundant plants, which will actually end up making it more difficult for our river to erode and smooth out its profile. So you can see how a changing climate can have both a positive and negative effect in terms of changing our river's profile. Now, in areas where we have sporadic rain, so our river may not be active all year, or during portions of the year it may have a smaller discharge, this is obviously going to mean it takes longer for our river to achieve the upward concave profile that it's aiming for. This is simply because our river will only have sufficient discharge to transport large amounts of sediment and to erode large quantities of material when the river has a sufficient supply of water. So let's say maybe in the spring, and then throughout the rest of the year the supply of water decreases, and so during those periods our river could just disappear, or it could go down to a very, very slow flowing river, and this would be unable to really shape the environment to any great degree. So you can see how climate is going to have an effect on our river profile. Now, the final factor which can affect our river profile is simply the stability of the conditions. How stable is our environment? Typically what will happen is if you have a nice stable environment, over time your river will achieve the profile that it's aiming for, and because the environment is stable, once it has achieved that profile, not much will actually change. You will have a steady rate of erosion which will be balanced out by a steady rate of deposition. Now, if the conditions change, so they become unstable, the river will obviously change as the conditions change. So you might see an increase in discharge or a decrease in discharge, and this will lead to changes in the rates of erosion or deposition. And this is obviously going to affect the shape of our profile. So stability is another factor that needs to be considered. Typically, the more stable the environment, once the river has achieved that profile, it will be less likely to have to change. All right, thank you for watching everybody, and have a good day.